Here is the next example. In this video, he's talking about, or he's asking us to find the current flowing through the 10 ohm resistor by using Thevenin theorem. Whenever you see Thevenin theorem, there are four important steps. Step 1, remove the element where we need to find the current, voltage or power, and then keep them as open terminals. I'm going to label them as AB. Step 2, find VAB. You can use mesh analysis, nodal analysis. Okay, so here I'm going to ground this. If I ground it, my VB equal to 0. So if I find VAB is nothing but voltage between these two terminals. VAB equal to VA minus VB. VB equal to 0. So all I need to do is find the voltage at this point. Okay, that is equal to the Thevenin equivalent voltage. That's what step 2 is. Step 3, find Z Thevenin. So there are two important things while finding Z Thevenin. While finding Z Thevenin, remove all independent sources and keep the dependent source in the circuit as it is. Keep the dependent source as it is. If there is a dependent source in the circuit, then connect a 1 ampere or 1 volt. It's up to you, need not to be 1 ampere. You can use 10 volts, 100 volts, doesn't matter, or 10 amperes, 100 amperes. You can use any number here as a voltage source or current source across the open terminals to find the Z Thevenin. It doesn't matter what number you use or what source you use, we should end up with the same amount of impedance. Now step 4, draw the Thevenin equivalent circuit. So here is Thevenin equivalent circuit with V Thevenin and Z Thevenin we found from step 2 and step 3. Okay, now connect your 10 ohm resistor which we removed in step 1, connect it back and find the current passing through the 10 ohm resistor, which is V Thevenin over Z Thevenin plus 10 ohms. Okay, now I'll move back to the step 2. In step 2, we need to find VAB. Okay, so before we find VAB, I have a mutual inductance here. So we know that if there is a mutual inductance, definitely there is an induced EMF. I mean, need not to be definitely depending upon the current flow in the other coil. So here, is there any current passing through this? There is no current passing through this because of the open terminals, but at the same time, there is some current passing through this. Okay, let me label that as I1. Okay, so I1 current is passing through this. Because of the current flow in this L1, definitely there is an voltage across L2, induced voltage across L2. At the same time, since there is no current across L2, there is no induced EMF across L1. So what I'm going to do to remove these dots, okay, what I'm going to do, I'm going to replace these dots and J4 ohms, the mutual inductance, by a dependent source. So the dependent source I'm going to draw is going to be right there. Okay, what is that source voltage? This is B, this is A. What is the source voltage? E equal to J4 times I1. Now you need to find the direction, which one is the positive terminal, which one is the negative terminal. So here current is leaving the dot, so the dotted terminal must be negative. So basically the negative terminal is on this side, positive terminal is on this side. Once I have the dependent source, now what I can do, I can replace this J4 and dots. Okay, now that makes it easier for us to find the VAB. So to find that, what I can do, I'm going to say the Vx voltage there. So VA minus Vx equal to J4 times I1, because there is no voltage drop here across J8 ohms or L2 because current passing through it is 0. So Vx, can I find that as J12 times I1? Okay, I can say J12 times I1. But do I know I1? I can find the I1, or I can use the voltage division rule. By using voltage division rule, Vx equal to, by using voltage division rule, Vx equal to total voltage, which is 14.14, at an angle of 0. We'll use the voltage division rule when two elements are in series. I would say this 5 ohms and J12 ohms are in series because there is no current passing through this J8 ohms. So total voltage multiplied by same impedance over total impedance, 5 plus J12, that will give us the voltage Vx. So to find that, convert this into polar form and then find the Vx. So I mean 14.14 over 5 plus J12 is nothing but 1.086 at an angle of minus 67.38. J12, I just kept it as it is. The reason behind it is I need to find I1. Basically, I1 is nothing but 14.14 at an angle of 0 over 5 plus J12. Okay, if I use this loop analysis, I will end up with I1. So basically, my I1 is nothing but 1.08 at an angle of minus 67.38. So I need to substitute this I1 here to find out the voltage there. So Vx equal to 1.086 at an angle of minus 67.38 times J12. This J12 I can write it as 12 at an angle of 90 degrees. So all I need to do is multiply these two numbers, 1.08 times 12, which is 13.05, and add the angles, 90 minus 67.38, which is 22.62. Same way, I found the voltage across this dependent source, which is J4 times I1. So 4 at an angle of 90 times 1.08 at an angle of minus 67.38, end up with the same angle, but the magnitude is 4.35. So the voltage, my final goal is finding VA. So there is no voltage drop across J8. VA minus Vx equal to J4 times I1, which I already know that value. I know Vx value. So VA equal to J4 times I1 plus Vx. I already have J4 times I1, which is 4.35 at an angle of 22.62, plus Vx equal to 13.05 at an angle of 22.62. So convert these two into polar format and add them. By the way, convert them to rectangular format, my apology. So 4.3 times, both of them are in the same direction, so even without converting them I can add them. The 17.4 at an angle of 22.62. okay. I'm going to convert this into rectangular format. If needed, I may use it. So that value is 16.06 plus J, 6.69. That's my VThevenin. So this is Thevenin voltage. VThevenin equal to VA equal to 17.4 at an angle of 22.62. Now my next step is find Zthevenin. While finding Zthevenin, remove all independent sources. While removing the independent sources, make sure you remove them. Actually, instead of remove them, all you need to do is replace them with their internal resistance. Okay, replace all independent sources with their internal resistance. Okay, so the internal resistance of a current source is infinite and internal resistance of voltage source is 0. So if it is a voltage source, independent voltage source short circuited, independent current source open circuited. Okay, so here I have a voltage source, so I have plus and minus sign instead of this arrow. So this is independent voltage source. Replace that with short circuit. At the same time, I have a dependent source in the circuit. If you have a dependent source in the circuit, you need to connect either 1 ampere source or 1 volt source across AB terminals to find out what is the internal impedance of this dependent source. I usually go with 1 ampere current source. So my goal is finding Zthevenin. So to find Zthevenin, can I put this as VA and VB? The voltage at that point is VA with respect to ground. Voltage at this point is VB with respect to ground. And I'm taking the bottom node as a reference node. That's a 0 volt. So VB equals 0. So Zthevenin is nothing but VAB over 1 ampere. Okay, so all I need to do is to find Z Thevenin. All I need to do is find VA. As long as I find VA, that is equivalent to Z Thevenin. Now I already did in the previous case. Okay, can I use the same VA? No, because the previous case has a source here and open terminals there. Now it is a different case. For sure, I have to recalculate what is my VA. And I mean, here you have I1, J4 I1. Make sure that I1 is the current. I1 is the current passing through this, though. That is I1. Okay, now you can use KVL, KCL, mesh analysis, and nodal analysis to find VA. I'm going to do the nodal analysis to find this value. So let me take this as the voltage at this point is Vx. My goal is finding VA. Can I say VA minus Vx equal to J4 times I1 plus J8 times 1 ampere, because the current passing through this is 1 ampere. Okay, my goal is finding VA, but at the same time I can say Vx equal to J12 times I1. Okay, so I'm going to replace Vx with this value. So VA equal to J4 times I1 plus J8 plus J12 times I1, which is J8 plus J16 times I1. That's my VA. Now I need to find I1 value to find out to find the VA value. So here I end up finding VA. Now applying KCL at Vx. So 1 ampere is entering, I1 and Ix are leaving. So I1 is nothing but Vx over J12, Ix is nothing but Vx over 5. So I found Vx as 4.615 at an angle of 22.62. So from there I found I1. I substituted this Vx value in this equation. Vx equal to J12 times I1. From here I found I1 value. Now I substituted I1 value in this VA. End up finding VA equal to 5.68 plus J 10.37. So VA is nothing but Z Thevenin in this case, because 1 ampere current is passing through it. So I found the Z Thevenin. So I have V Thevenin as 17.4 at an angle of 22.62. Here 17.4 at an angle of 22.62. Z Thevenin we have 5.68 plus J 10.37. Okay, now our goal is finding IL. IL is nothing but V Thevenin over Z Thevenin plus 10 ohms. V Thevenin is 17.4 at an angle of 22.62. Z Thevenin is 5.68 plus J10, and you're going to add another 10, so 15.68 plus J 10.37. Convert that into polar format. So 17.4 at an angle of 22.62 divided by, so when I convert this rectangular form into polar form, which is 18.8 at an angle of 33.47, so 17.4 divided by 18.8, which is 0.925 at an angle of minus 10.85. This is the load current passing through the 10 ohm resistor. So the important steps I want you to know. Okay, here once we open the in step 1, once we open the 10 ohms, there is no current in this loop 2. I2 is going to be 0 because it's open. Since there is no current, there is no induced voltage across this L1. Okay, because there is no current passing through it. That's the reason I don't have dependent source here. But there is a current passing through this L1. There is induced EMF there. Okay, so that value is J4 times I1. So where is this I1 flowing? I1 is flowing across this coil. Okay, remember that, because in step 4 what we did, here when we are doing the step 3, in step 3, make sure this J4 times I1, you need to indicate where that I1 is flowing. I1 is flowing in this J12 ohms. Okay, with this I'm done solving this example. I hope you understand. If you have more questions, please ping me in during my office hours. Thank you.